Today's video lecture is about finding the rule, and our standard today asks us to apply the properties of operations to generate equivalent expressions. So hopefully we remember that operations include all of the mathematical processes that we've learned so far, which is multiplication, division, addition, and subtraction. And we're going to generate equivalent, which is equal, expressions. Expressions can be another word for a problem or any kind of mathematical sentence, but it includes something new. This mathematical sentence includes an unknown value, and that unknown is called a variable. And we will discuss the formal definitions as we work through today. So please make sure that your template is pasted in appropriately before we start with our notes. We're going to work through a couple of different sets of patterns. And in each pattern, we have two components. We have a term number, and then we have a term value. When we're solving the pattern rule, we have to look at the term number and the term value and decide how the term number can be changed using one of our operations, addition, subtraction, multiplication, division, into the term value. So the term number would be considered the place in our pattern, and the term value would be considered the worth. So we can write that down. The term number is the place you are referencing in your pattern. So for example, if I was having a pattern with shapes, right? Something familiar that we know, and it said triangle, circle, square, triangle, circle, and I asked you what shape should be at term number 6, you would tell me a square. Number 6 is the place in which the square would appear, right? The term value in this particular example would be the square itself. It's the actual number or piece of information given to us at a specific term number or at a specific location in our pattern. So our first example has a term number of 1, 2, 3, and 4, and a term value of 4, 8, 12, and 16. It's important for us to think about term numbers and term patterns as pairs. So the 1 and the 4 are paired together, the 2 and the 8, the 3 and the 12, and the 4 and the 16. And the reason those are important is because I need to figure out what operation will take me from the term number to the term value in each pair consistently. So in order to get from 1 to 4, there's a process that I need to do, and that process is called the rule. The rule will be the same for every pair of numbers in this particular pattern set. So just to think about how we're going to figure out what the operation is to go from one term to the next, we want to identify a few different possibilities. So when we're looking at these patterns, we want to talk about whether we're growing or whether we're shrinking. And in order to teach us a little bit about that, we'll look at a short clip from Alice in Wonderland.
One side will make you grow tall.
So as the caterpillar tells us about the mushroom, we know that one side is going to make us bigger and the other side is going to make us smaller. So we're going to think about growing and shrinking in our term values. Based on the properties that we know several ways to grow and several ways to shrink when we're doing mathematical expressions. The first way of growing is basically addition, right? If I have the number 2 and I add 3, I'm growing that value to 5. Another way to grow is by multiplication. Again, 2 times 3 would be 6. I'm increasing my initial term number. So the opposite of addition, or a way for us to shrink our value, would be subtraction. And then a more complex way for us to shrink would be division. So when we're looking at term numbers compared to term values, we want to decide, first of all, are we growing or shrinking? And second of all, which operation are we going to test out first? So for example number 1, to go from 1 to 4, I'm most definitely growing, right? I can increase from 1 to 4 using addition or multiplication. I'll start out by trying addition. So if I add 3 to the number 1, I'll get the number 4. But if you remember what we discussed before, this process of adding 3 has to work for each pair of numbers in the pattern. So can my number 2 be increased by 3 to equal 8? No, right? If I have 2 and I increase it by 3, then I get 5, which is incorrect compared to my pattern. So I need to try again. And a method that I can use, again, to grow my term number to my term value would be multiplication. So the number 1 times 4 would equal the term value 4. Does 2 times 4 equal 8? Yes. Does 3 times 4 equal 12? Absolutely. Once I've checked several of these examples, I know that this process is working. So I can write the rule for my pattern number 1 to be n times 4, where n is my term number, and I'm equaling my term value. So at any time in my pattern, if I take my term number and I multiply it by 4, I'll equal my term value. So if I came all the way over here and I put a number 10 in my term number and I multiply by 4, I should get a term value of 40. And this should be correct in the grand scheme of my pattern. So let's try a few more examples. The second set of patterns goes from 3 to 6, 5 to 8, 6 to 9, and 7 to 10. Once again, I'm increasing in value, or I'm growing. So I'm going to start by trying to use addition to change from my term number to my term value. My first example is 3 to 6. So 3 plus 3 would give me 6. I need to keep this process throughout the pattern and check if it works. 5 plus 3 equals 8. 6 plus 3 equals 9. And 7 plus 3 equals 10. That tells me I'm correct in assuming that my rule is to add 3. Again, if I want to start with my term number, n plus 3 will equal my term value. The next example has us thinking about shrinking instead of growing. If I'm going from 20 to 10, I'm getting smaller. 30 to 15, 40 to 20, and 50 to 25. When you're shrinking, it's best to start by trying a subtraction example. So 20 to 10, using subtraction, I can say 20 minus 10 equals 10. When I test it for the next set in my pattern, 30 minus 10 equals 20, which is not the 15 that I'm looking for in my pattern. So this method is not going to work. The alternative method for shrinking a number would be division. So 20 divided by what number will give me 10? Well, in this case, 20 divided by 2 would give me 10. Does this work for the remainder of my pattern? 30 divided by 2 equals 15. 40 divided by 2 equals 20. And 50 divided by 2 equals 25. So this is the rule for my specific pattern here. N divided by 2 will equal my term value, right? This last example is a little more complicated, and that's for a reason that you will see as we try to attempt it. We are growing in our pattern to get from 4 to 6, 5 to 9, 6 to 11, 7 to 13. I am increasing in value. So I need to start with addition. 4 plus 3 equals 7. 5 plus 3 does not equal 9, right? It actually equals 8. So my addition method has failed me here. The other option for growing is multiplication. 4 times what number will equal 7? 4 times 1 equals 4. 4 times 2 equals 8. But there isn't exactly a number that I can multiply by 4 to equal 7. This is where I need to come up with a second piece of my strategy. I can go in two different directions from here. I can say 4 times 1 plus 3 will equal 7. And I have two pieces of information here. I have the multiplication by 1 and then the addition by 3 to get me to that term value. Or I can say 4 times 2 to get me to 8 and then subtract that last 1 to bring me back to the value of 7 that I'm supposed to be at, right? So I created these multiplication sentences, one below the value of 7 and one above the value of 7 to see which would work for the remainder of my pattern. The next step says I need to go from 5 to 9. So 5 times 1 is 5 plus 3 is actually 8. So this method fails me on my pattern for the second piece of the pattern here. However, the other method that we discussed to bring me from 5 to 9, 5 times 2 is 10, minus 1 is actually equal to 9. So this is working. Let's try the third example in my pattern. 6 times 2 is 12, minus 1 is 11. So this works again. So as you can see, sometimes we have to have two steps in order to be successful in moving from our term number to our term value. So the rule for this particular example is going to be n times 2 minus 1 equals, let's say, our value, v. So this is a more complicated pattern, but can still be solved using our simple operations. When you're filling out your left-hand side of the page, I want you to write the rule for the two examples that I have below in our proof section. Make sure that in your notes you have your term number, your term value, and also the rule on the inside of your foldable.